In this problem, we will do a conversion between Kp, the equilibrium constant in terms of pressure, and Kc, the equilibrium constant in terms of concentration. So anytime you deal with gases, you have to have the pressure or the concentration, one or the other. So if it's in pressure, it's a Kp. If it's in concentration, moles over liter, it's Kc. So here we have calcium carbonate going to calcium oxide and CO2 gas. We don't have to worry about this solid, calcium carbonate, nor that solid, calcium oxide, because they're solids. So solids do not go into our equilibrium expression. They have a pressure here of 0.105 atm, atm being the unit of pressure. Always quoted at a specific temperature, this equilibrium constant. So Kp here is going to be the pressure of CO2 gas. They tell us that the pressure here is 0.105 atmospheres. So, I mean, there's only one gas here, and that is CO2. So the pressure here is going to be 0.105 atmospheres, which would be our Kp value. They should have said the pressure of CO2 is 0.105 atmospheres, but they didn't say that. There's only one gas and there's only one pressure, so that's going to be it. Now, calculating Kc is going to be a little bit of a different dilemma for us. So remember our equation here. It's going to be Kp is equal to Kc times RT, all of that raised to the power of delta N. So let's figure out what delta N is for this reaction. Okay, so we have 1 mole here. Okay, the coefficient is 1. 1 mole of calcium carbonate reacts or is at an equilibrium with 1 mole of CaO, calcium oxide, and 1 mole of CO2. So 1 plus 1 is 2. 2 minus 1 is 1. So the correct answer here for the delta N is 1. Products minus reactants, final minus initial. The N here is moles, so it's going to be to the power of 1. And so we have our Kp here is 0.105 atmospheres. We're trying to find Kc. Don't have to worry about the units. R is 0.0821 liters atmosphere per mole Kelvin. Again, I really don't have to put the units here simply because our equilibrium constants are unitless. The T here is 350 degrees C, but we have to convert it to Kelvin. So make sure you convert it to Kelvin. All right, so that is going to be our Kc. So how did I do that? I have my Kp value, and I took that RT to the power of delta N and divided it through, and that isolates my Kc. So now to do this in our calculator, many ways to do this. A little bit of a complicated math, but nothing too grave. So it's going to be 0.105 divided by parentheses 0.0821 times 623, close the parentheses, and that should give us a Kc value of about 0.00205. 2.05 times 10 to the minus 3. Okay, what I find